Good day, students. My name is Mrs. Fakoya Elizabeth, and I will be your chemistry teacher for today's session. Today, we shall be discussing acid-base reactions, and under this lesson, we are going to look at 1. Simple acid-base titration, 2. Common indicators and their pH range, 3. Heat of neutralization, and 4. Calculations on acid-base titration. Learning objectives for this lesson. At the end of the lesson, learners will be able to 1. Define the following terms: acids, bases, neutralization reaction, indicators, and heat of neutralization. 2. Demonstrate acid-base titration. 3. Name the types of indicators and their pH range. And 4. Solve calculation problems on acid-base titration. Key vocabulary words are: A. Acids. These are substances which produces hydrogen or hydroxonium ions when dissolved in water. B. Bases. These are substances which will neutralize an acid to yield salt and water only. And C. Neutralization. This is a reaction in which an acid and a base quantitatively react together to give salt and water only. What is an acid-base titration? Acid-base titration is essentially neutralization reaction between the hydrogen or hydroxonium ion from the acid and the hydroxide ion from the base to form water. Titration technique is used to determine the average volume of the acid required to neutralize completely a known volume of the base. What are the apparatus used in acid-base titration? Number 1 is burette. Number 2 is pipette. Number 3 is conical flask. Number 4 is retort stand with clamp. Number 5 is funnel. Number 6 is white tile. Number 7 is standard flask. And number 8 is chemical balance. The pictures of these apparatus are shown below. Let us take a look at the setup for acid-base titration. In an acid-base titration, the apparatus are washed and drained before use. The burette and the pipette are rinsed with the solution to be used in them to avoid diluting the remains of water used in them. The solution of the acid is put in a burette, and the initial reading on the burette taken. A definite volume of the solution of a base is put in a conical flask and an indicator added. The acid in the burette is then gradually added into the solution of a base with shaking until the reaction is complete, as signaled by a sudden change in the color of the indicator. This is the end point or neutralization point or equivalence point of the reaction. The final burette reading is then taken. Let us look at common indicators and their pH range. What is an indicator? Indicators are weak organic acids or bases that change colors depending on the hydrogen ion concentration of the solution. They are used in acid-base titration to detect the end point of the reaction and to test for acidity or alkalinity of a solution. The table below shows the list of the indicators commonly used, the colors they exhibit in various solutions, and the pH range where color change takes place. In the table below, we have 4 types of indicator. Number 1 is litmus. The color of litmus in acidic medium is red, in neutral medium is purple, in alkaline medium is blue, the pH is 7, and the pH transition is 6.0 to 8.0. Number 2 is methyl orange. The color of methyl orange in acidic medium is pink, in neutral medium it is orange, in alkaline medium it is yellow, the pH is 3.7, and the pH transition is 3.1 to 4.4. Number 3 is phenolphthalein. The color of phenolphthalein in acidic medium is colorless, in neutral medium is colorless, in alkaline medium is pink, the pH is 9.1, and the pH transition is 8.3 to 10.0. And number 4 is methyl red. The color in acidic medium is pink. In neutral medium, it is red. In alkaline medium, it is yellow. The pH is 5.1 and the pH transition is 4.4 to 6.3. What is heat of neutralization? This is the heat liberated when 1 mole of hydrogen ion combines with 1 mole of hydroxide ion to form 1 mole of water. Generally, when an acid and a base is mixed together, the reaction vessel becomes warm. This shows that heat is given out when an acid is mixed with a base. Stay tuned, and when I come back, we are going to look at calculation under heat of neutralization. Thank you. Welcome back. We are going to look at calculation on heat of neutralization. Heat of neutralization is calculated by using the expression heat given out over number of moles. Heat given out is equal to mc theta, where m is equal to total mass of solution, c is equal to specific heat capacity, which is 4.2 joule per gram per Kelvin, and theta is equal to temperature rise. Anytime heat is given out, the enthalpy of the reaction bears a negative sign. Example: 100 cm cube of 0.2 molar HCl neutralizes 100 cm cube of 0.2 molar NaOH. Find the heat of neutralization of the acid if the rise in temperature is 14 Kelvin and the specific heat capacity of the solution is 4.2 joule per gram per Kelvin. From the question, the mass of the solution was not given. The specific heat capacity is given as 4.2 joule per gram per Kelvin, and temperature rise theta is given as 14 Kelvin. Heat of neutralization is equal to heat given out over number of moles. For us to calculate heat given out, we must look for the mass of the solution. From the question, we were given 100 cm cube of HCl and 100 cm cube of NaOH. Adding this together, we get 200 cm cube or 200 gram. It is important to note that 1 cm cube is equal to 1 gram. Therefore, 200 cm cube will be equal to 200 gram. Heat given out is given by mc theta. The mass of the solution is 200 times specific heat capacity, which is 4.2, times temperature rise, which is 14. When we multiply this together, we get 11,760 joules. Don't forget that anytime heat is given out, the enthalpy of the reaction bears a negative sign. To find the number of moles of the acid, we are going to use the expression concentration times volume divided by 1000. We are dividing by 1000 to convert the volume of the acid given in cm cube to dm cube. Concentration of the acid is 0.2 times volume of the acid 100 divided by 1000. This gives 0.02 moles. Now, the heat of neutralization is heat given out by the acid, which is minus 11,760 joules, divided by the number of moles of the acid, which is 0.02 moles. Solving this will give minus 588,000 joules. To convert this to kilojoule, we divide by 1000, and the final answer is minus 588 kilojoule per mole. In practice, the standard heat of neutralization delta H between a strong acid and a strong base is minus 57 kilojoule per mole. It is a constant. Calculations on acid-base titration. Titration technique is used to determine the average volume of acid that will neutralize 20 cm cube or 25 cm cube of the base. The parameters of a solution. The three parameters that are used to describe a solution are its concentration C, the amount N of solute in the solution, and the volume V of the solution. Now let us look at the mathematical relationships between these parameters. Number one is molar concentration. The SI unit is mole per dm cube. Molar concentration C in mole per dm cube is given as amount N in moles divided by volume V in dm cube. Using symbols, we have concentration C is equal to amount N divided by volume V. If we make volume V the subject of the formula, the expression becomes amount N divided by concentration C. And if we make amount N in moles the subject of the formula, we have concentration C times volume V. Number two is mass concentration. The SI unit is grams per dm cube, and it is expressed as mass M in grams divided by volume V in dm cube. And number three, we have molar and mass concentrations related by the mathematical expression mass concentration is equal to molar concentration times molar mass, or making molar concentration the subject of the formula, it becomes mass concentration over molar mass. If we make molar mass the subject of the formula, it becomes mass concentration over molar concentration. In order to compare the concentrations of two or more solutions of the same or different chemical substance, their concentrations must be expressed in the same unit. Stay tuned and don't go away. Welcome back. In an acid-base titration, the volume of the base is represented by Vb and that of the acid is Va. The concentrations of acids and bases are denoted by Ca and Cb respectively. Since the process is neutralization, in which an acid is made to react with a base, we have to write down the equation for the reaction occurring between the acid and the base and deduce the mole ratio of the acid and the base. The relationship between Va, Vb, Ca, Cb, Na and Nb is given by the expression CaVa over CbVb is equal to Na over Nb. Example: A is a solution of an impure tetraoxosulfate 6 containing 4 gram in 250 cm cube of solution. B is a solution of pure sodium hydroxide containing 6 gram per dm cube. If 25 cm cube portions of B required an average of 15.50 cm cube for complete neutralization, calculate the A. Concentration of B in mole per dm cube. B. Concentration of A in mole per dm cube. C. Concentration of pure acid in solution A in gram per dm cube. And D. Number of hydrogen ions in 1 dm cube of solution A, given that Avogadro's number is equal to 6.02 times 10 raised to power 23. Solution. Starting from question A, the concentration of B in mole per dm cube, we are going to use the expression concentration of B in gram per dm cube over molar mass of B. From the question, concentration of B in gram per dm cube is 6.0. To calculate the molar mass of NaOH, we are going to add the relative atomic mass of sodium, oxygen, and hydrogen. This is equal to 23 plus 16 plus 1, which is equal to 40 grams per mole. Therefore, concentration of B in mole per dm cube is equal to 6.0 over 40, which is 0.150 mole per dm cube. It is important to note that concentration is written to 3 significant figures. B. Concentration of A in mole per dm cube. The equation for the reaction is 1 mole of H2SO4 reacting with 2 moles of NaOH to give 1 mole of Na2SO4 and 1 mole of H2O. From the equation of reaction, the mole ratio of acid to base is 1 to 2. Since we know the concentration of B in mole per dm cube, we can calculate the concentration of A in mole per dm cube using CaVa over CbVb is equal to Na over Nb. Va is 15.50, Vb is 25.00, Ca is unknown, Cb is 0.150, Na is equal to 1, and Nb is equal to 2. Substituting the values, we have Ca times 15.50 divided by 0.15 times 25 is equal to 1 over 2. Making Ca the subject of the formula, we have 0.15 times 25 divided by 2 times 15.50. Ca is equal to 0.121 mole per dm cube. C is concentration of A in gram per dm cube. To calculate this, we are going to use the expression concentration of A in mole per dm cube times molar mass of A. Molar mass of H2SO4 is equal to 2 times 1 plus 1 times 32 plus 4 times 16. 2 times 1 is 2. 1 times 32 is 32, 4 times 16 is 64. Adding this together, we have 98 grams per mole. Concentration of A in gram per dm cube is equal to 0.121 times 98, which is equal to 11.858 grams per dm cube. D. Number of hydrogen ions in 1 dm cube. Recall that number of moles is equal to number of particles over Avogadro's number. Particles can be atoms, molecules, or ions. Therefore, number of hydrogen ions is equal to number of moles of hydrogen ion times Avogadro's number. 1 mole of H2SO4 will dissociate to give 2 moles of hydrogen ion and 1 mole of SO42-. The ratio of H2SO4 to the hydrogen ion from this equation is 1 to 2. Number of moles of H2SO4 is equal to concentration in mole per dm cube times volume in dm cube, which is equal to 0.121 times 1, and this gives us 0.121 moles. Number of moles of hydrogen ion will be equal to 2 times 0.121, which is equal to 0.242 moles. Therefore, number of hydrogen ions in 1 dm cube of A is equal to 0.242 times 6.02 times 10 raised to power 23, which is equal to 1.452 times 10 raised to power 23 ions. Revision question. Number 1. Define heat of neutralization. Number 2. Name 3 types of acid-base indicator. Number 3. A solution contains 1 gram of pure NaOH in 250 cm cube of solution. Calculate its concentration in A. Gram per dm cube, B. Mole per dm cube. Thank you and stay safe.